Okay, so in this video we're going to focus our attention on chemistry. Yeah, that is stoichiometry, limiting reagent. So I believe if you have done chemistry, you have come across this. So this is just a simple theoretical point of view. The most interesting part is us seeing things from the practical point of view. Okay, so as it is well said, a limiting reagent or reactant is one that is used up completely in a reaction before the reaction is complete, to say so. So meaning, as two or more reactants are being put together, the products will depend on that particular limiting reagent. Okay, so it's used up completely, completely depletes in the chemical reaction. So in this case, I'm using combustion as an example, and I'll say combustion of alcohols. So I'm using alcohols for a purpose, okay, because what I'm using in an experiment, just a few seconds, let's say a few minutes from now, I'm going to show from a practical point of view how we can clearly get the picture here. So what I've used here is ethanol reacting with oxygen, giving us carbon dioxide, of course, water, as well as energy that is in joules. Okay, so for me to determine which of these is a limiting reactant, I had to use masses, and you can also use moles, so on and so forth. There are a lot of ways in which you can calculate the limiting reactant depending on how the question has been brought. Yeah, so I'm using a simpler method. There are a lot of complex methods, but I don't want to confuse anyone, sorry. Yeah, so here we are comparing ethanol and oxygen. Of course, I'm going to use the balanced equation. Okay, so I get the ethanol, I equate it with oxygen. This is the relative molecular mass of ethanol, and this is the relative molecular mass of oxygen from the balanced equation. Okay, so I say in this case I have deliberately given ethanol 1.2 grams and oxygen 3.4 grams. Okay, so after equating here, I'll pretend I don't know the mass of oxygen. I'll say, okay, what mass of oxygen can react with 1.2 grams of ethanol? So I pretend here we don't know the mass of oxygen, that we have not been given. Okay, so I equate here, this is the 1.2 grams of ethanol. Here we equate it like that. Here we say we don't know what's there. We pretend of course we have been given, but we want to know we want to be sure if 1.2 grams of ethanol really needs 3.4 grams to react with. Okay, so after we equate here, what you're going to find is 2.4 grams. So meaning 1.2 grams of ethanol does not need 3.4 grams. It needs 2.5 grams, of which it simply means when immediately as these two reacts, immediately the mass of oxygen reaches 2.5, this one will finish completely, meaning this one is the limiting reagent and oxygen is the one in excess. So what I'm using here is in an experiment is methylated spirit. Okay, methylated spirit. Okay, so there we have it. This is the methylated spirit. So I've put the same quantity, and what we have here is water. So what I'm going to do here is when an alcohol reacts with water, because like for example, say this is an alcohol liquid. When you add water to this, like this water, and add it to this, it becomes alcohol aqueous. What do we say so? Because like yeah, it becomes more like you are reducing the strength of the alcohol that you have been given at that moment. Okay, so what I'm going to do here is that I'm just using two dinner plates there. We have the candle there to give us the light that we need. Yeah, so I'm going to take this is just methylated spirit on its own. I put it in this plate. Okay, so I'm going to get this methylated spirit and put it in the other plate, and get This is almost the same quantity of water, and put it like that. Okay, so now I'll just try to mix it so you can see things happen mixing inside there. Okay, so let me just try to do this. All right, so I'm going to light these two up. I see what will happen. Okay, you're able to see what's happening there. I've lit it up. You can see the flame there. This is one where we have water and spirit being mixed together. Okay, before this one finishes, I'll light this one up that only has spirit on its own. Okay, so you can see the difference there in terms of okay, there we have it. So okay, so please, as you light this, try to remove anything that might burn, because I'm doing this from my room. I don't have I don't have a lab here, so I'm doing it from my room. So just try to put things away that might be a hazard. Yeah, so okay, so from this point of view, what do we understand when you look at what we have here? Oxygen we have, and the fuel that in the alcohol we have it here. Okay, so now in terms of this one, why was the flame not too high compared to that one? It's quite simple. This one, the strength was reduced because of the water that we had to mix with. Okay, so meaning in this case the ethanol that we have is the one that was the limiting reagent. So from this simple point of view, it's quite easy now for us to see the clear picture of what we talk about. And so the limiting reagent, and what does it really mean, and how does it apply, because these apply in a lot of ways in our everyday life. Okay, and besides, like I guess one of the contents of methylated spirit, like almost like according to the information that I got, it's about 90% is ethanol. Then the other percent is a content of methane as well. They say there's an ethyl group and a methyl group, so as to since methane is toxic, so they put it there to prevent such a spirit to be used as a cheap alcohol. Okay, so that is all from this video. Yeah, thank you.